Hi. So in this section, we're just going to talk about skewness and how we use the mean, median, and mode to show skewness. And it's really short and it's just basically eyeballing it. Like it's really cool. I like skewness. I can just look at a histogram and or a box plot and just eyeball it, like, whoa, this is skewed. And so I think that's important to understand that when you eyeball it and you relate it to the statistics that's within your data. So there are a few types of skewness, right? And we're going to talk about each one of these throughout the class many times. And this uniform means that all the data frequencies are the same. And so this can happen with schools, like how many students in every fourth grade class. Usually it's uniform because they want them to all have the same number of students in the class. The bell shaped is where it has a peak right in the middle and it splits your data in half. So that's where like you would have a perfect Q2 cutting the rectangle in half on your box plot. And so whatever's on the left, that area is on the right. So it looks perfectly cutting that data in half at that peak. Skewed right means that it tails off to the right and it peaks out on the left. The last one is skewed left, and that's when it tails off to the left and peaks to the right. And those are those are the four different types of skewness that we have. Okay, well, what does this mean to the mean, median, and mode, right? So let's go ahead and take a look at that. So the four types of distributions, we have the uniform, the bell-shaped, right, and left. So bell-shaped means that the mean, median, and mode are all equal. Okay. Skewed right means that in order to skew right, there has to be something happening at this peak, right? And so the mode is the greatest value, meaning that you'll find in quantitative data what is most frequent. The mean is the middle value, and then that mean will be greater than the median. So the median will be the smallest value. Well, what does this mean? This means according to your graph, the highest point on the graph is the median. And it will be the smallest. So here's the median. So to the right of it will be the mean. And to the right of that will be the mode. So the mode lives over here somewhere. And the mean lives to the right of the median. And the median will always be half of your data. So skewed left would mean the opposite, right? That now the largest value is your mode, and then your median's to the right of it, and then the smallest value is your mean. And so if on the graph, this means that your mode is the largest value. So here's the median, and so the mode is over here. Here's the median, and then the average is over here. So the median will always be the highest peak because that's what we use. It's just we use the resistant statistic in order to show the highest peak, and it just means usually the mode we don't really look at as much. Like we just look at it as in terms of the mean and median, and if the mean and median are equal or close, they don't have to be identical, but like 24.9 and 25, that's pretty close. Then you're going to see a most bell shape here. If you find that your average is more than your median, it's greater, then you know you're going to have a little bit of skewness to the right. And if your median is larger than your mean, then we know it's going to be skewness to the left. So if we went ahead and looked at our previous example right here with the college textbooks, and we saw that the average was 304 and the median was 320. So this means that the average was less than the median. So when the average is less than the median and the median is greater, what does this mean our data would look like? Well, when our median is greater than our mean, it looks like we're going to have a little bit of skewness left. And so in this case, when our median is greater than our mean, then we're going to see a little bit of skewness to the left. If we had the mean greater than the median, we would have a little bit of skewness to the right. Okay, and the same goes for any box plots. We would see where those box plots lie in that median and see if the median is skewed to the left or to the right. And we can see where it tails off with box plots by seeing how long those whiskers are on each side. Okay, so just to kind of give an idea, I'll do the bell-shaped box plot. Right, and then here's the whiskers, and the whiskers would be even on each side, and the median is right in the middle. And so this would be like a bell shape. And of course you have some x-axis on the bottom. Okay, and then if I wanted to do the other box plot, see, and do skewed right, the median would be, with skewed right, the median is the smallest value. So that means that it's over here. It's one of the smallest values, and it's not far from the minimum. And then we have like some sort of longer whisker over here to the maximum from Q3. Okay, and this would be, oops, skewed right. And of course you have some sort of x-axis here. Okay, and then skewed left, go down a little, let me do the box. Skewed left means that we have the median greater than the mean, so therefore the median has to be over here on the right side, and the Q3 is not far from the maximum, and we have like a longer whisker over here on the left side to the minimum. And so this would be skewed left. And of course we have the x-axis on the bottom. So those are the three different types of box plots. And when I say you want to look at where the median lies, well, remember the median is this bar, and so if it's bell shape, it'll cut your rectangle in half, right? Here's the rectangle, cuts it right in half. That's bell shape. Skewed right means that the median is smaller than the average, so it has to be over here on the left side and a longer whisker to that maximum. Skew left means that you have the median greater than the mean, so the highest peak would be here and then a longer whisker to the minimum. Okay,